So, welcome to this last session of the meeting here. I'm sure all of you have had the same experience I had, that there's been a really remarkable amount of great science here at this meeting. What's been also, I think, quite chastening, at least for me, was at the very beginning when the first speaker said, well, you know, they think maybe in the United States, maybe only 10% of people know what synthetic biology is, and Hong Kong is maybe only 1%, right? So although we're excited about this field, there's not a whole lot of knowledge about it in the public. And that's not going to change for a long time unless there's some way that all of this wonderful science is turned into something which is really something which is going to have an effect on the people, right? There's going to be some big society benefit to the whole thing. So until we begin to see that, then nobody's going to know very much about what synthetic biology is. So but we're not going to see any impact on the field until we begin to get some way in which this turns into products, right? And the only way we're going to get products is if the scientific community, those of us in the science field, of course, interact with those in the investment community. So that's the idea of this last meeting here. See, how can we actually turn this all into practical benefit by having groups of people who actually are people giving out the money and the people who are actually receiving the money to have some sort of dialogue in your company, see how this would work. Now, I'm neither a synthetic biologist nor a venture capitalist. But one experience I did have is I sort of grew up in the Department of Biochemistry and Biophysics at UCSF. And so I had the good fortune to watch Herb Boyer going off and starting Genentech. I had the good fortune of watching Bill Rutter going out and starting Chiron. So I was able to see what happened in those early days of biotech. Now, is there a seat left at the end? All right. Zach?
You wish you'd gone with them?
Right, yeah. That's right. It's been a wasted career, right?
There's still hope. He's not that
yeah.
old.
Zach, do you want to come up and join us? Yeah, come on. Might as well. There's an extra chair, right? So yeah, one of the things though that you know, biotechnology now is a very stable, mature field, but what in the Bay Area right now is really exciting. There's a huge buzz going on that synthetic biology is the next thing. I mean, it's really just like, for me, it's what's going on now is very much the way it was 25 years ago. We're having actually, once again, venture capitalists coming around the halls and saying, what do anybody have that's coming out that we could invest in? It's not like that in biotechnology. So there is a buzz going on in this whole area. So one of the things that we want to talk about is whether this is a valid buzz and what's going to happen in this area. Another thing, though, if you try and think if this is going to be another new field like biotechnology was, have we learned from the mistakes we made in trying to commercialize biotechnology, and can we actually do it a little bit more intelligently this time through? So one particular thing we'll hopefully get from the panelists is a discussion of how much different is it now, since the world is now a globalization place. When biotechnology started 30 years, no one was thinking very much of globalization. But now we do. And one of the reasons we are thinking, we're having this panel here, and we had this meeting in Asia, is because nowadays you immediately think when you have a new field of how globalization might work. So what I'm going to do then is ask the people on the panel to spend a couple of minutes saying what they think, introduce themselves, say how they've been involved in either the venture field or the synthetic biology field, and what they see as being the opportunities and challenges in the field. And then I'm going to open this meeting up to you to ask questions of them, so we can or to make your comments, so we can get a dialogue going. So I'm going to start off with Jack Wadsworth, because Jack has this enviable position. He was actually here at the beginning of the beginning. He was actually involved in setting up Kleiner Perkins, and Kleiner Perkins helped set up Genentech. So Jack, why don't you start and tell us what your impressions are?
Okay.
It's on. Okay. Reg, thanks. It is a little disconcerting to me that you said you don't know anything about synthetic biology, because all I can say about my introduction to synthetic biology is that it was through you. So we'll have to have a talk after this panel. Reg mentioned Kleiner Perkins. I didn't start Kleiner Perkins; they started it. But I will use that as an intro, and I'll be very brief. I think among the people on the panel, I need to say that I'm not a venture capitalist. I never really have been a venture capitalist. I've been one of those obsolete guys that are now referred to as investment bankers, and we're all trying to figure out what to do with ourselves after this crisis. Having said that, I was instrumental in beginning Morgan Stanley's venture capital business, and one of the tenets that I always used in our own strategy was that financial people should be involved with venture at the stage where the business had proven itself to the point that it could be analyzed from a financial point of view. And that really is what led us to our relationship with Kleiner Perkins that began in 1982. We helped them with Fund 3, and it was out of that fund that came many of the computer-related technology companies. Genentech was before that. But it's a principle that I still feel is very, very important. The very best venture capital is done by individuals who've had experience in technology, who've had experience running companies, who've had experience in the real world, in the marketplace, and understands what to do, therefore, when an early stage investment gets in trouble. And the question is marketing, manufacturing, science, proving the product, and the young company can get the benefit of that experience to help either rechart the direction, change the metrics, or decide not to invest any more money in it. Investment bankers are best at analyzing something when, in fact, it needs finance, and therefore the investments we made were alongside Kleiner Perkins at later stages when the companies had really proven that there was something to be excited about. I think what I'd like to turn the discussion to is the relationship between science and new company formation and venture capital. I thought a lot about this when I came to Asia, because one would think, as you look at Asia from the United States, that there would be huge opportunities for early stage company creation in places like Japan and Korea and India, Hong Kong, Singapore. What we all discovered in the early days coming out here is that the phenomenon that is Silicon Valley or Route 128 or other places in the United States is really about great science, great universities, great companies that are doing important science. But the great companies that are doing important science in the United States have a long tradition of scientists, great engineers, great inventors, leaving those companies and forming new companies. Hewlett-Packard and Fairchild have probably spawned more new companies than any other companies in the world, and there are plenty of examples of that. In Japan, you have the science, but you don't really have any tradition of entrepreneurs leaving companies to found new companies. And pretty much the same as in Korea. And curiously enough, I think, I mean, it's a dangerous generalization, but the best science in those places is really being done by companies, not in universities. And so without the tradition of entrepreneurs moving out of the companies, you have almost no new company formation in the technology field, and therefore no venture capital industry. I mean, there really is no venture capital industry in Japan or Korea. Likewise, in places like Hong Kong and Singapore, where there could be that phenomenon, the science at the university level is a new thing. And these small countries really don't have the kind of companies that create the sort of scientific opportunity to create new companies, and therefore there really has traditionally not been any venture capital, as we think of it in California, in places like Hong Kong or Singapore. China is a whole new subject, huge opportunity, entrepreneurial activity that is mind-boggling. I won't even spend any time on that because it's not the subject here, but I think if there is a California of Asia, it will be China. In its early days, I have a venture capital firm in Beijing called Cheiyuan Ventures, which is focused on IT, primarily the internet, the wireless internet. And I think that may be one of the next big things. Why are we here in Hong Kong? What I think synthetic biology represents, and this is what I got excited about when we came here to think about doing SB 4.0 in Asia, is that the synthetic biology science is relatively new. As it's practiced in the United States, it's still a small group of people that are making the biggest difference. And if this conference has an impact on the University of Science and Technology in Hong Kong, as I think it already is, the scientific activity here will explode. And if the government supports that through some thematic research grants as opposed to the traditional way of just handing it out through competition, Hong Kong could very quickly make a difference. And on that, I would conclude that if there is then to be a venture capital business here backed up next to a synthetic biology science that's developing, it will be because the science develops, not because the venture capitalists come here and try and encourage it to develop. The science comes first, venture capital comes next, and therefore I think the next 3 years will be very telling as to whether or not this conference has had the kind of impact that I personally hope it will.
Sure. So my name is Tali Somek. I'm from a small family venture fund called Musea Ventures that my father and I run. My background is a little bit different because my background is actually, my training, if you will, is primarily in political activism and software. And the intersection of those two was in the free and open source software movement. And for the past 10 years, actually for the first 6 years after college, I was really involved in software consultancy and free software and sort of saw how between Web 1.0 and Web 2.0, there was this transition from essentially needing $1 million to build a website, needing a $300,000 server and then the rest on software licenses, to needing about $50 so you can have a development server and build Facebook. And so the lesson there was that if you could lower the capital requirements enough, you could inspire innovation in a way. And allow people to be very creative and come up with new ideas. And so when I was first introduced to synthetic biology, it was through Rich Newton at Berkeley. My father was a very successful semiconductor equipment manufacturing executive. He was with Applied Materials for 24 years and then Novellus, and so he was very familiar. I grew up in the semiconductor industry, if you will. So when we met Rich Newton, he asked me what I'm interested in doing, and I said, well, I'm thinking about doing a Linux company. And if you knew Rich Newton, you knew he was a sort of unique character, a visionary. He first started a company called Cadence, which was the first electronic design automation company. And then when they stopped listening to him, he went and started Synopsys. And now Synopsys is the #1 company, and Cadence is the #2. So I said I was interested in starting a Linux company, and he said, that's stupid, do synthetic biology. So I figured, okay, if a guy like this tells me something like that, I should listen. And as I got into synthetic biology, I learned more and more about it. I learned that the ethos, the principles behind it, are very much in line with the free and open source software movement. And as an extension of that, I think we can see biotech 2.0, if you will, where we have very affordable capital for students, for garage technologists, as Rob defined himself, as smaller companies in the biofuel space, to be able to pick and choose parts and no longer need a $30 million Series A, which is quite important nowadays. So in terms of Reg's question of what is the future, what are the challenges, it's really to develop a community and understand that there's a great deal of wealth in freedom, if you will. And so that's in terms of what our investments are in synthetic biology. It's really trying to identify what are the next products, the next investments, the next tools that are needed to lower the cost to do the next biofuel or the next antibody treatment and so forth.
Hi, I'm Carl Handelsman. I work at CMEA Capital Management. That's spelled like cool men eating apples. We have over $1 billion under management. Before y'all get excited and ask for half of that, we look for opportunities to invest dozens of millions of dollars in dozens of people that can do something that will be economically viable in a 2 to 3 year period, which is pretty constraining if you think about it. But I'm a huge believer in synthetic biology, and in a sense, at the dawn of biotechnology, there was a big race to go after the first products, and there were two approaches. One was to clone, and one was to synthesize the genes. And it turns out early on, synthesizing the genes won the day the first time. But what we've seen is a continuous improvement in the power of synthetic biology. So I remember going to the Synthetic Biology 1.0 at MIT, and a very exciting meeting. But the organizers, I think, decided to wait 2 years, right, to the next one. And then the next meeting was more than 10 times better. And the meeting's been held every time since. And there's been a real acceleration. George just mentioned in his last talk about how there's a 10x increase in the power of, say, sequencing or synthesis every year. And that's an unprecedented change. When you have an ability to change things by orders of magnitude every year, you enable brand new types of ideas. Some of you are probably thinking, when Sidney Brenner was talking about ivermectin, and wow, I could, you're thinking, I'll just put it straight in the plant, and I go get that pathway. And it's great that small numbers of researchers can now do experiments at a much, much faster rate, and they can do things that nobody ever felt possible before. And it's something that from where we sit at CMEA, where we like to find deep science that we can couple with really great visionaries to build important new industries, that I'm incredibly excited about.
My name is David Hansel with Exceed Capital. I realized it was 30 years ago I met Reg. I was working at a bench at UCSF, starting a 10-year search. It was in signal transduction to find a protein that was phosphorylated. The good news was I did. But after that, I went into industry. I came back from a postdoc and had a choice of a tenure track position at UCSF or this thing called stock options. And I really didn't know what they were, so I went to work at Molecular Dynamics, but my first job was in sales. So the first thing is you never know where you're going to wind up coming as a scientist. In the last 17 years, I still keep going back to the bench. I founded a gene discovery company, Aomica, mostly building tools and then finally leveraging them. Using DNA sequencers, I was on the Megabase project, I've done microarrays. And about 2.5 years ago, I found myself in between jobs. And what did I like to do? I like to hang out in universities and go to classes and talk to professors and graduate students. And I thought, well, this is kind of cool. And a friend of mine who had been a professor at Berkeley raised money and started his own venture capital firm. He said, David, you want to come with me? Because I believe that the best breakthrough science is going to come from universities. And so what we're going to do is we're going to talk to smart professors and smart graduate students and see what happens. And it's been a little over 2 years. We have 11 portfolio companies. They often start with a professor will say, that guy is my best student. And we'll spend a lot of time trying to figure out a business plan. Or we'll start with a professor who has a burgeoning new technology or something that we thought was really great and interesting. A lot of what happened, Red said, can you talk about some of the things, the difficulties or the challenges when we start companies? We actually often start a company from where a student or the professor didn't think there was a company. One of the things we always have to do, you can imagine, before you can give a professor and a student $1 million, you do have to have a money-grubbing tie. So invariably, we're often bringing in a business function. And the thing in biofuels or synthetic biology is there are no executives out there, or not many in the very beginning. And so it's been a fascinating process. As we start companies, we will bring in during the first phase, the seed phase that we fund, usually by ourselves, we bring in somebody who maybe has been in the drug business for 10 years and wants to do something that has no FDA, but who knows how to run a business, who can mentor and start it. So we'll see how it turns out. We're a very small fund compared to CMEA. But we do believe that we're going to start with things from the ideas and solutions from universities.
Hi, I'm Jay Kiesling. I'm a professor at the University of California, Berkeley, division director at Lawrence Berkeley National Labs, and I run a biofuels institute called the Joint Bioenergy Institute in Emeryville. I've started, 3 companies, two of them with George. The 2 with George are, and I assume he'll talk about them more, Codon Devices and LS9. About the same time as Codon got started, I, with 4 postdocs in my lab, founded Amyris. Amyris was, so I'll talk a little bit about that because I think it's rather unique in how it got started. Amyris was started on the idea that we could produce isoprenoids in microbes. Our first product was a product that we couldn't make any money on, an anti-malarial drug. You heard about that in 2 different talks at this meeting. And so how do you start a company on something you can't make any money on? The first thing you do is you go get a grant for doing the work. We went to the Gates Foundation and got a $42 million grant for the work, 12 of which went to Amyris. And that got us started. You still have to be able to make money when you start a company like that. So we said, we're going to give away the technology. It's so important. We'll give it away to people in the developing world. They don't have to pay. Any company who licenses the technology, who make the drug, won't have to pay a royalty for using the technology. But in return, the company gets the microbe that was created out of that to use for synthesizing other chemicals. So one could synthesize bulk chemicals, specialty chemicals, or biofuels. And in fact, that's what Amyris is now doing. So about a year after the funding from the Gates Foundation, when the funding came in, we started Amyris. It immediately started with about a dozen people or so. One of the former postdocs who helped found Amyris went to a university to be a professor. The other 3 are still there as founders and on the management team. We, after a year, got the A round in funding, but we were in a unique position because we had a company that was already valued at about $10 million, and so we got $20 million in follow-up funding. That was the round A, but it was a unique round A. The venture capitalists really didn't know what to do with us at the time because we had a unique business plan not to make any money. But fortunately, we found venture capitalists who really valued the idea of doing something for the developing world and giving away the technology, and I think that's what attracted them. So we got some great investors in the company, and Amyris took a B round a little while ago, and that was north of $100 million. And now they've got 200 plus people, I guess. I don't really know what the number is. And they're working hard on biofuels. A little bit about doing entrepreneurial things in academics. I try to encourage it in the lab to the extent possible. So one of the the nice things about the funding from that we had gotten from the Gates Foundation is that we were expected to patent everything, and that was to protect it so that we wouldn't be blocked in using any of the intellectual property. And while we had done patents in the lab before, it was always a bit of a struggle with the university because Berkeley, like many, I think, public institutions, they don't file at risk, which means that basically you have to have a company that will pay for all the patent costs before the university will go out and do the patenting. And with the Gates Foundation, they guaranteed that they would pay for all the patent costs up front, as long as they had a license to the technology up front. And so this really brought into the lab to a great deal the idea of patenting to everything we could to the extent possible. And we did it in a way that wouldn't interfere with publications. And so I think it was a great learning lesson for many people in the lab at the time, and hopefully that's carried through. And so to that extent, we've always tried to encourage graduate students and postdocs being entrepreneurial to the extent they can be.
So I was attracted to technology development as a undergraduate, becoming a graduate student, and I landed in Wally Gilbert's lab where he was in the process of starting Biogen in 1978 or so, which was about a year after I got there. And I had been working on some automating sequencing and had worked with a company called Bio-Rad just the year before that, which didn't go anywhere. But anyway, I worked at Biogen for a while as a postdoc, and then fast forward to various things that Jay has mentioned, a couple that have done in collaboration either with Vinod Khosla, who's in the energy field, or Flagship Ventures, various other ones. Codon devices, LS9, a few in the DNA sequencing and personal genomics fields, a little less relevant to this audience. But they kind of illustrate what Jay was just touching upon, but which is if you're going to develop technology, I felt, and I think it's reasonable, that it's not sufficient just to publish because it really doesn't have much impact. It used to be when I was a graduate student, all you had to do was publish a little methods paper that do it yourself, and people would make their own enzymes and they'd make their own, radioisotopes and and so forth. And then it transitioned to, the enzymes were made for you, and then the kits were made for you. And pretty soon kits were too hard to use. You had to have an instrument that would use your kit for you. And the whole point now is really just to raise money for your instruments. And try not to become an instrument yourself, yeah. So I think I'll just move this along so we can get to the questions, which I'm really looking forward to. Yeah.
My name is Zach Serber. I am a scientist at Amyris. I am a group leader as well. I have never spoken to a VC except socially, so I arguably really don't belong up here, except that I probably represent the majority of people in the audience in that respect as well. 13 months ago, I was a postdoc at Stanford and had no intention, 14 months ago, I had no intention of going into industry. I was a hardcore academic. Both my parents are school teachers, and this was a radical announcement to them as well, that I was considering something other than that. Part of the reason why I did was because I saw what was going on at Amyris. I knew some of the people there, and I saw what they were doing as worthwhile. The Artemisinium project in particular, that was the project that brought a lot of the early timers onto the team. They've expanded their focus, of course, and that's interesting as well, to consider all the things that one can do with this technology. It's very important, I think, when one considers in the audience what you might do with this technology, since there is so much that can be done, to consider all the implications as well, that there are, in addition to profits, there's good that can be done with this. And since there is so much that can be done around that, those those projects, the ones that can do social good, should be considered first. That's my piece.